Polar coordinate system. Most students only know of one coordinate system, which is the rectangular coordinate system. But there are other coordinate systems. We have the spherical coordinate system, we have the cylindrical coordinate system, and in this lesson, I will introduce the polar coordinate system. The polar coordinate system is useful for tracking and locating objects whose movement or orbit is elliptical, circular, or spiral, and whose orbit is centered on a fixed point. We call the fixed point as the pole. Examples: the movement of planets around the sun. So the sun is our pole, and the orbits of our planets trace an ellipse. Now, this is only a model of the solar system. The truth of the matter is, the sun is really not fixed in its position. The sun has its own wobble. It is wobbling. It also has its own small orbit. But in our model, we look at the sun as something that is fixed in its place. The movement of stars around the center of the galaxy. So the stars around the center of our galaxy, the Milky Way, it is rotating in a spiral motion. And so when we are studying the movements of these stars around the center of the galaxy, it's the polar coordinate system which is going to be very helpful. We also use the polar coordinate system when we are working with mechanical systems where the movement is circular, such as satellites, rotation of blades, etc. Okay, so this is the components of the polar coordinate system. We have the fixed point, we have the origin, and we call the origin the pole. A point P is going to be assigned two coordinates, r and theta. R is its distance from the pole, and theta is the angle the point makes with the horizontal axis. And the angle is measured clockwise. The angle can be in terms of degree measure or radian measure. So in this example, point A is 3 units from the pole, and it makes an angle of 0 degrees. Point B is 3 units from the pole. It makes an angle of 90 degrees from the horizontal axis, from the positive side of your horizontal axis, measured counterclockwise. Point C is 2 units from the pole. It makes an angle of 60 degrees. Point D is 2 units from the pole, and it makes an angle of 240 degrees. Okay, so starting from the positive side of your axis, horizontal axis, point D makes an angle of 240 degrees. How do you plot points in the polar coordinate system? So your graphing plane or your graphing paper. So in the old days, we plot the points on a piece of paper, but this is how the paper ought to look like. Okay, so you have these concentric circles. So each circle contains a set of points, and the radius of that circle is telling you the distance of those points from the pole. So how do you plot points? Let us plot the following points. A is a point whose distance from the pole is 1. So what you do is you pay attention to the unit circle. So to the first circle here. So point A is going to lie somewhere there in the unit circle. And then after that, what you will do is you will trace an angle that is equal to 120 degrees. Starting from here, will bring you there. Okay? that is 120 degrees. So our point A is going to be that one. How about B? Point B. Point B is 4 units from the pole. So you pay attention to the circle whose radius is 4. And then, starting from the positive side of your horizontal axis, you will trace an angle that is equal to 270 degrees. Okay? So this is 90, this is 180, and this is going to be your 270 degrees. Point B is going to be this point with coordinates 4 and 270 degrees. How about point C? So when you see a negative r, what you do is you ignore the negative sign. You pay attention to the positive, to the absolute value of that value of r. So this one is a point that lies in the unit circle. And then 0 degrees. Okay? But that is not yet point C. Okay? Because r here is equal to -1. So what you are going to do is you will now move that point to the opposite end of the diameter of your unit circle, and it's going to be that point. That is point C. Okay? D is equal to -2 and 90 degrees. Again, you pay attention to the circle whose radius is 2. Okay? You ignore the negative sign. And then you trace an angle that is equal to 90 degrees. Okay? But that is not yet point D. What you will do is you will move that point to the opposite end of the diameter of your circle, and that is that point. That point is point D. The angle measure of your points in polar coordinate system need not be always in degree measure. And in fact, in integral calculus, we are going to use radian measure more often. So where is point E in our plane? Again, we will pay attention to the circle with radius 3. Where is point E there? Well, from the positive side of your horizontal axis, you will trace an angle that is equal to, or whose radian measure is 3 pi over 4. Okay? So this one, from here to there, that is pi. So we will only trace 3/4 of a pi, and 3/4 of a pi is somewhere here. The distance of that point from the pole should be 3. That one. How about this? Point F. Okay, -4 and pi over 6. So F is there in the circle whose distance or whose radius is 4. And then we will trace an angle that is equal to pi over 6. Okay? Pi over 6 is here. This is pi over 6. Okay? From here to there, that is pi over 6. But because our r is equal to -4, you will move that point to the opposite end of your diameter. So this one is going to be your point F. Write the polar coordinates in both degree and radian measures. So this time we are given points in our plane. We will write their polar coordinates, both in degree measure and radian measure. Okay, point A. Let's begin with point A. So r is equal to 2. And the degree measure of that is, this is 30 degrees, 60, 90, and so that one is going to be 120 degrees. So A has coordinates 2 and 120 degrees. 120 degrees is equal to 2 pi over 3 radians. Okay? So this is pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. But 4 pi over 6 is 2 pi over 3. How about point B? So r for point B is equal to 3. And then we will trace an angle, okay? And And the angle from the positive side of your horizontal axis to be, this is pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. In radian measure, that is going to be 5 pi over 6. But in degree measure, that's going to be 150 degrees. How about point C? R for point C is equal to 4. In degree measure, the degree measure is going to be, this is 30 degrees, okay? This is 60 degrees. So it's going to be 60 degrees. 4 and 60 degrees. In radian measure, that's going to be 4 and pi over 3, okay? Pi over 3. How about point D? So point D, R is equal to 3 and the angle measure is 180 degrees. But you can also write it as -3 degrees. In radian measure, that is going to be 3 and pi radians. How about point E? So point E lies in the circle whose radius is 2 and the angle measure is 300 degrees. In radian measure, that is 5 pi over 3. So this is pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, and that one is going to be 5 pi over 3.